Okay, with page 2, we start with problem number 5. We see here we have a graph of the derivative of f, and the domain is from 0 to 2. And the question asks, what's the value of x at which the absolute min of f occurs? So we know that an absolute min, would occur either at an endpoint of our interval. So that means we need to check out f of 0. We have to check out f of 2. And then it could also occur at a critical number. And so certainly we have a critical number right there at x equals 1. Now, this is a situation where we have a relative max. Right, the derivative is changing from positive to negative. Since f of 1 will be a relative max, it's definitely not going to be an absolute min. So f of 1 is out. 3/2 is also out because that's not a critical point and it's not an endpoint. So we need f of 0 and we need f of 2. All right. So, well, what do we know here? If we start comparing things, well, we have some positive area between 0 and 1. So we know that f of 1, I'm sorry, that should not be a prime symbol. F of 1 is going to be greater than f of 0 because of that positive area right there. All right. We also know that we have more area that we have to analyze between 1 and 2. All right. And we can see that this will, because this area is below the x-axis, that f of 1 will be greater than f of 2 because we will be subtracting this area from f of 1 since it's below the x-axis. So now that may not really help us because we can see that f of 1 is bigger than both these, which we knew anyways because f of 1 was going to be a relative max. All right. So now we're comparing, all right, and basically we're saying, do we gain more area between 0 and 1, or does f, compared to how much area f loses between 1 and 2, all right, and so the magnitude of the area here is larger than the area there. So if we kind of picture this here, if f of 0 is wherever, right there. All right, well, by the time we get to 1, we're going to increase some. All right, we're going to increase whatever this area is to get from 0 to 1. This is our graph of f here. All right, but then we're going to lose more area by the time we get to 2 because there's more space down here. So our answer is D. Number 6 here, you can see I made a note that this is in fact parts. So we have to figure out u and dv. All right. So we're asked to evaluate the integral from 2 to 4 of f of x times g double prime of x dx. All right. So how do we handle this one? Well, we have to pick a u, and I know that we're used to using that whole Lipit mnemonic, but that doesn't obviously help us here since we have two functions and we don't have any specific type of function. That's okay though. Remember, the idea behind Lipit was it was helping you to select the ideal u and the ideal dv. Okay, but the overall idea of picking a u is that you want to pick something that we can take a derivative of, and the overall idea of dv is you want to pick something that we can take the antiderivative of. All right. Well, if we look at our table, we have g double prime. We don't have g triple prime. So if we were to make u equal to g double prime, that's not good because then du would be g triple prime and we don't know what to do with it. All right, so when we do this situation right here, we're going to make u equal to our f of x, and we're going to make dv equal to our g double prime of x. Okay. That means that v will be the antiderivative of g double prime, or g prime, and du will be equal to f prime of x dx, and we're told that f prime of x is equal to 3, so du will be 3 dx. All right, so now if we put all of this into play here, all right, we know that this antiderivative will be equal to, again, it's uv minus the antiderivative of v du. So we're going to have f of x times g prime of x, that's our uv, minus the antiderivative of v du, and du is 3 dx. So I'm going to put the dx on the inside, and might as well get the 3 on the outside. All right. And yes, this is a definite integral, so we are going to have the whole thing evaluated from 2 to 4. We're just not going to do it yet, but that 2 and 4, they haven't gone away. Okay. Before we evaluate the 2 and the 4, we need to take care of this antiderivative, and so the first part will remain the same, and the antiderivative of g prime is just g. And again, this is all from 2 to 4. So that means we're going to have f of 4 times g prime of 4 minus 3 times g of 4 minus, and now the same thing but with 2, f of 2 g prime of 2 minus 3 g of 2. So f of 4 we can see from the table is 13. G prime of 4 is 7. G of 4 is 9. F of 2 is 7. G prime of 2 is 1. G of 2 is 2. So we have 13 times 7, which is 91, minus 27, and then we're going to subtract 7 minus 6. So 91 minus 27, so 91 minus 30 would be 61, minus 27 would be 64, so we have 64 minus 1, and our answer is 63. Last one on this page, big G is the antiderivative for f, and if big G of 2 is equal to negative 7, what is big G of 4? All right. So big G of 4, this is our new value. The new value is equal to the old value plus all of the change from the old value, the old x, which is 2, to the new x, which is 4. And the change is represented by g prime. But if g is the antiderivative for f, that means that if we want g prime of x, that will be f of x. All right, so we're going to have g prime of x here, but really g prime is f, and g of 2 is given to be negative 7, and we can see that this matches with D.